Assalamu alaikum. This is Dr. Usman Sadiq Paracha, and today we would be having our lecture number 25 of the subject Applied Quantitative Analysis and Practices. So in our previous lecture we had a discussion on inference about the slope. Basically the whole focus of the discussion was on simple linear regression analysis, how it is performed, and what are the major factors which basically make the foundation of this analysis. In this case we had a discussion about the concept behind regression, how different methodologies can be used for regression analysis like least square method, and then how things like measures of variation play an important role in laying the foundation of regression. So it's very important that things like sum of squares for regression and sum of square for errors, they play a very important role, and then form the basis to calculate coefficient of determination, or in other words, which is also termed as R square. Now R square basically defines how much the model is able to explain the phenomena which we want to measure through that respective model. So in that we were discussing about the details which are involved while testing these basic things, specifically the hypothesis testing through regression analysis. And in it, first was regarding the inference about the slope, how, because the slope is an important part, it basically detects the change in the value of x or independent variable, how that change basically impacts the change in dependent variable. So that's why we have to make inferences about the slope, because this is quite evident that as we are not dealing with the whole population, so we have to select a sample. So when we are selecting a sample, then it is quite much important that any figure which has been reported through any kind of analysis should have been tested for the possibility that whether that same figure which has been generated through that specific analysis would be scored again when we are considering other samples from the same population, because the consistency of that result matters a lot. So that's why we have to conduct inferences about any figure which has been reported through this kind of statistical analysis. And in this, the slope in regression is a very important part, and that's why we have to have performed this inference thing. So then we had the Dtest for slope, just like as we had Z-test for the values. Here in this specific case, we have to perform Dtest in order to find out the probability of having that value or slope which is reported, whether that probability is high or low, and how much can we say that this is evident that this kind of result will be repeated again for the same kind of samples if extracted from the same population. So here we had gone through an example here for the Dtest which was conducted for slope, and then we had F-test for significance. Basically F-test is quite much important when we are trying to have a look over the overall model credibility, how much the whole model is valid. So we have to perform an F-test and find out whether that is significant or not, also its value. So based on that we can decide whether model as a whole is feasible or not in this case. Then we had a brief discussion on the confidence interval estimation for slope and how that is conducted, and what's the concept of confidence interval here. So just going through the recap of previous discussion which we had. This was how we discussed about the slope and how basically we were focusing on our this hypothesis generation, and in this case this is quite evident that the null and alternative hypothesis can be tested through this test statistic here, as you can see, and basically here we have to find out the answer for the main basic question, whether there is any linear relationship between x and y. So we are going through the same exercise of null hypothesis statement and alternative hypothesis statement. We have got certain formula for testing the t-test. So after going through that, we discussed about the example regarding this t-test here, and how we calculated the regression basically here, and how this coefficient basically was measured. Now based on that, we had to conclude whether there was any kind of relationship in the example which we have been discussing. Then we had the result displayed for a typical t-test, and its coefficients were displayed along with the standard error and the p-value. Again, the t-test value was then compared and with the p-value, and as the p-value was less than 0.05, so we had to reject null hypothesis in this case. So this was just an example how results are reported in softwares and how the relevant values of these kind of variables matter. And then we discussed about what's the phenomena behind this acceptance and rejection of null hypothesis, how we draw this normal distribution diagram, and then how the level of significance are here identified as already displayed in this diagram. Then how we determine the critical values for t-test here and how they are determined, and the regions in which we have to accept the hypothesis or reject the hypothesis. So based on that concept, basically then we reject or accept our null hypothesis and make our conclusion. So then we had the same discussion about the p-value, what's the importance and how it's affecting our level of significance here. So it also affects our decision for acceptance or rejection of our hypothesis here. So we discussed about that previously. Then we had a brief overview for the F-test statistic, and here you can see that we discussed about the formula and the formula notation here. Then you can see that again the SSR and SSE are playing an important role in determination of F-test statistic. Once this F-test statistic is basically calculated, then based on that we have to see whether it has got relevant significance here or not, which you can see here. And based on that significance and the F-test value, we finally decide whether this whole model, which you can see in this form here, whether this model is valid or not, should it be accepted or rejected. So here basically you can see that in total basically the concept behind the F-test statistic is kind of same which we had been following for Z-test and T-test. However, you can see here that these values and the curve and the way the region in which the null hypothesis is accepted and the region in which null hypothesis is rejected, these regions differ in F-test as compared to T-test and Z-test, as you can see in the diagram. So based on the plotting of that F-test value which we just found out, then we have to plot it and we have to see whether this value here specifically falls under the acceptance region or rejection region, and based on that we have to accept or reject our null hypothesis. So based on this null hypothesis, acceptance or rejection, then we conclude our final statement here, which you can see here, in which it is stated that house size in fact affects the selling price, the data for which we have been testing in all these examples. So once we have gone through this, then we got into the debate of calculating the confidence interval, and we stated the formula for that. All the values normally are given to us, and then how these values basically are reported in various softwares, and what are the main values which matter. So how can we conclude based on the values which have been just given in the table? We just wrote the statement about that and we discussed about it here. Then we had basically our main conclusion, that what does these lower and upper limits of this confidence interval mean. So based on that, you can say that we made our final conclusion, which is pretty much evident here in these two boxes. So once we did discuss about the confidence interval application and its formula, then we had a discussion on the concept of confidence interval, because it's not just about stating a formula and then just trying to find out the values for the formula and finding the result, because the concept and the interpretation of that result matters a lot. So that's why it's important that we go through its main concept, that what the phenomena is and how this whole thing affects our result in this case. So we had an example of a typical confidence interval after we had just discussed its concept, and in that you can see we had certain population and then we had standard deviation here. Also you are given certain sample size. So here we were given a certain question regarding this whole example. Then we calculated the limits of various means. In fact, you can see that in total 5 samples were withdrawn, and each sample has been reported to have different mean, which you can see here. And likewise, as the mean was different, then again its lower and upper limit was again different. So the possibility of whether all these mean values may contain the main population value mean, so we just wrote down the possibilities here, which you can see here, with only one sample giving us a negative answer here. So after going through this example, then we stated the rules, that how to interpret this example, and then basically how we are going to calculate this 95% interval and what does this mean. So after going through that, this was the main basic conclusion, that when we have a sample in which our mean and standard deviation, normally both are unknown, then when we take a random sample, then we have to draw some kind of confidence interval, in which you can see here that if you are making a level of significance of 95%, then you can state that you are 95% confident about whatever the result is obtained. So this was just an example of the estimation process which is normally carried out. Then we discussed about the general formula, which was used to calculate the point estimate, and again the confidence interval upper limit and lower limit here. So once these values have been calculated, then our calculation of standard error is a bit easy, and then we came upon the situation in which we know that if population mean, in which we are dealing with population mean, we don't have any standard deviation, or sorry, and in this case, one case that when in standard deviation is known, and on the other if the standard deviation is unknown. So we just stated the formulas for if the standard deviation is known. It's a standard formula, and again it's involving the z-value of the normal distribution. So based on that, our confidence interval estimate is made. But mind you, this is important that this is only applicable if our standard deviation is known. Again, we have to see that the sample basically is normal. Then we had discussed about the concept behind that. We had already discussed that one case of z-value, how to find out the critical values. We have already gone through that exercise. Then how to go through its lower limit and upper limit here, and then what are the implications of that. So then we had a discussion about the common levels of confidence and what were the main common values of z here, you can see. So basically in this case the z values and the relevant confidence coefficients are displayed in this table, which make our interpretation of the situation easier. So then we had a discussion about what are intervals and what's the probable possibility, and then in one case if this interval is out of range, then what's the implication on our total result. So basically this was the diagrammatical presentation of this kind of situation. So based on that, then we can move ahead with our further decisions. Then we are now dealing with the typical example which we have to go in this lecture. So now basically once we have discussed about our confidence interval estimation, so let's go ahead with a few examples here. And as you can see here that we are dealing with the sample of 11 circuits, which you can see just a diagrammatic representation of that. And basically in that case you can see that there are 11 circuits from a normal population. Again, this is an important statement. And then we have got a mean resistance here of 2.2. Now also we are given the population standard deviation here. So this makes it a very conventional example, and we have to basically determine a 95% confidence interval here, in this case for the true mean resistance of the population. So we are given a sample, but in this case we are given the mean resistance of the population and also the standard deviation of the population. So all what you have to do is to find out the 95% confidence interval here. So going through the example, we already know that if our standard deviation is known, then we have to go through this formula as we have discussed it before. So we know the mean and also the critical value of z. So all what we have to do is just put the values, and then based on that we can easily find out our confidence interval in this case. So we have got the upper limit and our lower limit in this case, which does give us a faint idea of how much the mean value of the population would be ranging from. So then going through that, then there is an interpretation now that of the same result, that based on this thing, as we have taken the z values for 95% confidence interval, so based on it we can assess that yes, we are 95% confident that the mean basically would lie between the upper limit and lower limit, which has been calculated in this example. So basically maybe through this example, basically true mean may not be calculated in this case, but then 95% of intervals which have been performed in this case will contain the true mean. So that's the exact interpretation of this solution basically. So Normally we cannot again say for sure that what's the exact true mean, because again we are dealing with probability here. So once we are dealing with probability, we are never sure of the whole exact value in this case. So that's why we can only say how much percent we are confident in our findings here. So then, going through that, after this confidence interval thing, one important aspect which we had ignored in the past lectures was related to correlation coefficient. And we had very much assessed that correlation coefficient, though it is calculated. But again, as we have discussed before, that whatever coefficient or whatever kind of statistic which is calculated in a sample, that has to be then basically tested whether if other samples are withdrawn from the same population, would the same value would be reported there or not. So here basically once we have to make sure whether the values which have been reported through this correlation coefficient, would the same values be reported if other samples are withdrawn from the same population. So we have to go through the same hypothesis formulation, and we have to state our null hypothesis, we have to state our alternative hypothesis as well. And here in this case you can see that our null hypothesis is pretty much evident here, which you can see that no correlation may exist between x and y. Then we have got a certain formula for the test statistic here, which you can see, and here basically once the values for all these formulas is known, then we can find out the ultimate t-test value. So then again, in this case we have just taken the example of the same square feet and house price example here. In this case we just want to answer whether there is any linear relationship between the size of the house and the price at this level of significance of 0.05. So in this case, in one case we are shown that okay, fine, null hypothesis states that there is no correlation, and alternative hypothesis that the correlation does exist. Now here we are also given the degree of freedom, and in this case we just depute the values which we have been given, and you can see here that basically this t statistic clearly indicates to us whether our null hypothesis or alternative hypothesis is true or not in this case. So basically the formula is simple enough, and basically when you know the relevant values in the equation, then it's easy to formulate an answer. Then we discuss about the concept behind this t-test statistic, and again, as we have obtained this value of 3.329, so now the issue is that we have to draw the same normal distribution curve which we have been drawing previously, and as you can see here we are trying to basically test this value for level of significance equal to 0.05, and you can see basically that here our these two critical values are now calculated, which is the standard critical values for t, and again it's a two-tailed test, so we are not sure about the direction, and also we have identified the rejection region for null hypothesis here, which you can see at the end, and likewise the middle range, which is for the region which is the acceptance region for null hypothesis. So we just tried to plot the value which is calculated from this t statistic, and here in this case this is 3.329. so by plotting it here we can see that this value is coming on the region which is for rejection of null hypothesis. So based on that, yes, we can conclude that there is evidence of linear association in between independent and dependent variable. Now here you see we cannot say again for sure that basically there is for certain linear association, but we can say that there is no evidence for that, because we still have 5% of this level of non-significance which can play an important role. So there is still a possibility that again our basic hypothesis may go wrong, just giving rise to our type 1 or type 2 errors in this case. So that's why we just state that there is evidence that there may be linear association between these two variables. So once we have calculated this t-test and its plotting in various regions, then we reject our hypothesis, which as the value is basically outside the acceptance region here. So coming to the regression analysis, because these are the small concepts which are used in regression analysis, like confidence interval and even the calculation of correlation, which is calculated in regression analysis as well, because these little details matter in regression. So what are the pitfalls or the discrepancies of regression analysis here? Now basically one of the biggest pitfall is that lacking an awareness of the assumptions underlying least square regression. So most of the people who do use this analysis have no idea about the conditions which are necessary to be met for regression analysis. So without testing for conditions, running a regression analysis on certain group of values may end up in our values which may be unrealistic, and at further stage may give us proof that actually in our previous analysis was not all right. So basically these assumptions or conditions are very important before regression analysis is formed, and then even after when the regression analysis has been formed, it is equally important that the variate basically, or the conditions for variate are equally met. So it's quite a strict basic ruling for all these kind of regression tests. Then the second most important pitfall is regarding having no knowledge about how to evaluate these assumptions, because even if you know that these assumptions need to be met here, then most of the people do not know how to evaluate or test these conditions. So once there is no know-how, then normally what people do is just go ahead with the running the regression analysis, which in fact is not advisable. Then again, there is another lack of awareness in regarding if certain conditions are not met for least square methods, then there's lack of awareness if there are any other alternatives available. Now these basically alternatives are there. If one method of regression is not feasible and basically the conditions for that specific method are not met, then it's not the end of the world, and we can switch to alternative methods here. But again, there is very less awareness for alternative methods here. And then the most important issue is regarding application of regression model with no theory or with no knowledge of the theory. Now this is very important, because we have discussed again and again that SPSS or any kind of software would give any kind of answer for any kind of analysis or for any kind of data which is entered there, because the software has no idea about the theory behind that and no idea about the logic. So basically it can even give us a strong correlation between number of football players in all the clubs in Brazil and the number of people who eat ice cream in winter or not. So basically these two variables which I have just mentioned have logically or theoretically no connection in between them, but again, as they are just numbers, they are just figures, so their values basically can be entered in the software, and to software these are just bunch of values in which it has to find out a certain end value with a certain formula. So based on that, applying the regression model without any knowledge of the theory is very basically backfiring episode, and in that case you may be able to get the figures in one form or the other, but then you won't be able to give any kind of explanation for such a model. So this is very important that the whole theoretical perspective is studied in detail, whether this is the human resource management area, or project management area, or financial management, or marketing management. In any case, the detailed theoretical know-how is necessary, and once the know-how is there, then we can extract the relevant variables to represent our concepts in the model which are there. So once the right concepts and right variables are identified, then a regression model can be run in order to know that what's the phenomena which is behind all this modeling phase. So then again, the other important issue regarding regression analysis is the extrapolation outside the relevant image. So in this case, we have already discussed that if, let's say, we have got a group of values basically which are represented here in the form of a line, and our main line lies here and the end limits are here, then we can only extrapolate to find out the values in between these limits, which are the end limits at top and bottom. And if we go beyond these limits, then that would more become a kind of a prediction tool, which basically regression analysis is not. So extrapolation beyond these minimum or maximum values would not make any sense for regression analysis. So this is highly discouraged in a regression case as well. So once we have gone through that, then there are certain strategies how to avoid these discrepancies. And the first strategy is that we should start with the scatter plot always. And that is a thing which we have been discussing previously, that whenever we have to run any kind of analysis, we have to give importance to scatter plot, basically in terms of measuring or having an assessment or initial assessment of any kind of relationship between any kind of two variables. So that's why the tool of scatter plot is of vital importance in any software, and it does gives us a brief idea of the nature of relationship, and then once we know about that specific nature, then we can particularly decide that which basically course of action is necessary to move ahead in order to avoid the pitfall for any type of regression. So that's why it's scatter plot is also kind of an early warning system. So it does gives us a very much good idea of what we are going into. So once we have gone through that, then we also have to perform residual analysis to check the assumptions. And again, it is vital that we shouldn't just be satisfied with the conditions applied for initial variable which are to be inducted in regression, because initially it may be possible that exact picture of the data may not be obtained. So that's why it is important that residual analysis, which is conducted after the regression is run, is performed. Now here in this case, in regression analysis, first thing is that we have to plot these residuals basically on independent variable to check for violations of assumptions such as homoscedasticity. So this is one assumption which needs to be importantly followed. Then likewise we have to use the other tools like histogram, normal probability plotting, or box plotting, or even stem and leaf display to thoroughly check out that which part of the values or which part of this whole data set is not normal, and it should be reported to basically the relevant quarters which are doing the analysis in this case. Now these residual analysis basically have to be performed to check the conditions, and in this case you can see that we basically are typically using the same tactics, the same tools for performing the analysis of residuals here, or error terms, and we have to justify the same issues which we have done previously for initial data set. So once we have gone through that, then also again, if there is any violation of any condition, then we have got alternative methods for models as well. So this is not necessary that this present model should only be tested, and if it's to be rigorously followed, and if there is a violation, then we won't be getting anywhere. So in order to avoid that, we can use alternative methods. Now in this case, if there is no evidence of any kind of condition violation, then basically we have to carry on with the test for the regression coefficient significance, and also we have to construct the relevant confidence intervals at the prediction level and non-prediction level. So now here in this case these are the various conditions, and then again it's again told that we should avoid making predictions outside these relevant range values, because once you go outside, then this regression analysis does not hold true for this whole analysis. So these are the important pitfalls which need to be addressed. So this was related to our regression analysis debate which we have been carrying on, and we discussed in detail about what are the assumptions which are required, and what are the conditions which need to be followed for performing regression, what was the concept behind this whole regression phase, and basically, as there is a lot of difference between correlation and regression, regression is preferred, because in correlation we are not able to determine what's the cause and effect from a phenomena of this whole variable testing process, and regression we can show for some instance that for instance we can say for sure that in regression there is one variable which is identified as predictor, the one which is causing the effect, and based on that we move ahead with the further conclusion. So regression is very much important from that aspect. It does give us an idea of cause and effect phenomena, so which normally other strategies don't give us, like correlation and other facts. So based on that, we have to basically determine whether the errors which have been produced as a result of that regression, whether these errors are justified or not, because if there is any problem with the errors, then again we have to rethink our model. But this is one rule, that based on the values, abnormal values of these basically assumptions, it is not necessary to basically delete that specific case or cases in order to ensure that assumptions get justified, because that is not the solution which we are trying to acquire. So in this case, this is quite evident that we can detect, and we should detect only what's the real situation and whether the assumptions are met or not. If they are not, then we have to go for alternative regression methods. Now, as we have gone through this whole theoretical aspect of regression, let's have a look of how to test this regression in SPSS. So going to the software, basically SPSS, we have got our data file in which we are being shown a few columns, a few values which have been coded, and the main columns in which we are interested are number of students who have appeared in board exam and number of students who have passed in board exam. So here basically we are given the data for these specific two. Now I just want to know that whether the number of students which are appearing in exam, does their number or enrollment has an impact on the number of students who have passed in that specific examination. So I have been given the relevant percentage or the figure also of the number of students which are enrolled in different schools here. So I just want to find out whether the number of students who have passed basically are dependent upon number of students who have appeared. So let's have a check on that. So here in order to test this, let's have a look at its scatter plot first. So let's go to the chart builder and let's have a look at the scatter dot on the left panel, and we just want to find out between the simple scatter plotting, which basically is our concern. And in this case you can see in x-axis we can plot number of students who have basically appeared, and also number of students who have passed. So basically from that we can calculate what type of relationship exists in between these two. So by clicking on OK, going to output window, you can clearly see the scatter plot here, and this scatter plot basically gives us a faint idea that yes, there can be a relationship between these two, and we can also draw the line for this case, and in this you can say edit window and separate window. So once the separate window is open, then we just click on the diagram and we just want to know about the average line which would be portraying here. So click on this, and here again we are requiring a linear line. So click on close, and here you can see that from the line here, this kind of quite evident that there is an inverse relationship between number of students passed and number of students who have appeared. So basically this does portray that number of students who are appearing on, or in other words, number of students who have passed in board examination in government schools have a strong relationship with the number of students who are enrolled in that before that specific exam. So based on that, some solid conclusions can be drawn here. So once we have gone to this, let's come to the regression part. So we click on analyze and regression, we click on linear. Now here you can mention whatever is your dependent variable here. So in this case the dependent variable basically is number of students who have passed basically. So we want to find out the relationship between number of students appeared and number of students passed in the board exam. So I just click on number of students who have appeared, and we click on arrow, and you can see that the two variables are now enlisted here. And again, this is a simple linear regression, so the method which is to be found is entering method. We will discuss about this in detail in future lectures. So let's click on statistics, and in statistics we require R-squared change, we also require descriptives, we require collinearity diagnostics. Then case-wise diagnostics, here you can reduce the outlier variables to 2 standard deviations. And again, we would like to know about the Durbin-Watson test, again, which represents if there is any correlation between one or two or three independent variables. Now here, as we have got only one independent variable, therefore there is no sense of highlighting Durbin-Watson, but we will discuss it in detail regarding multiple regression, which we will discuss ahead. So clicking on continue, let's click on plots, and here you can see all the plots for residuals can be made in order to assess the conditions for regression, which we have discussed before, and based on that we can move ahead with our further examples. Here in this we can see the plots which can be derived from this analysis. For now we are only interested in the standardized residual plots, which is the histogram and normal probability plot. But we would be having a detailed discussion about what are residuals and what are the different type of residuals and how we can make use of them. So by clicking on continue, we have given the relevant values. Again, we would be clicking on options here, and you can see here that you can mention the basically criteria for the probability, and here it can be seen that f is 0.05 and at 0.10 it would be removed. We can give the individual f value, but that's not advisable here. Then here in this case also we are dealing with the missing values phenomena, and in this case exclude cases listwise mean here that if any single value from any single column is missing, then all the relevant values related to that case would not be included in the questionnaire, basically not in the questionnaire analysis. Then we have got exclude cases pairwise, in which basically we have the option to maneuver, but normally again it comes with some strict rules. So let's click on continue and click on OK. So now as we have run the regression statistic, you can see that we are given the descriptive statistics of both the variables here, past and appeared, and then we are also given the correlations, in which how much correlation exists between the appeared and past, and here you can see that the Pearson correlation is 0.774, and again in the model here we can say that the variable which has been entered here is appeared. Again we are given here the detail of dependent variable, which is past students. Now come to the model summary here, because this is important, because in this case first model is presented and the R which has been calculated here is 0.774. Now in this is a kind of a rule of thumb, because if we have got simple linear regression, then the coefficient reported in this regression, specifically of that R square, would be the same as that of simple correlation coefficient. So that's why we basically move on to R square, basically, which is as 0.599. And after R square, the other important part is adjusted R square, which has been shrinked to avoid any errors. But again we can see that 0.59 is repeated here. That means that there is very little chance of any kind of error which has been detected, or which may have been detected along the lines. So here we are also given the standard error of the estimate, which is 19.8. Again we can compare it with dependent variable values, and based on that we can claim whether this standard error of estimate is normal or not, acceptable or not. Then we are given the R square change, which again is the same as that of R square, because here the R value in fact is not changed at all. Then we have got F value here, and it's the same F statistic which we have been talking about before. And our concern here is that F change here is value 1611. However, whether it's significant or not is shown here, and you can see here from this column that its p-value is less than 0.001. So that makes it an acceptable model, and also a good one, because 60% variance in basically dependent variable is explained by its predictor. So this is the standard model summary. We would be going to the details of rest of the analysis in next lecture. So basically in today's lecture we had a discussion about the concept of confidence interval, why it's important, and how we can calculate this interval here. So basically, why is it necessary to calculate confidence interval for different kind of tests, and it does gives us a range in which we can rely on. So we just went through a few examples of confidence interval calculation, how to do it, and in a specific case when the population and standard deviation is known, then how to calculate this confidence interval conventionally through the formula. Then we discussed about the application of Dtest for correlation coefficient, why it's necessary and what's the concept behind that. We also discussed whether this Dtest basically is in this case following the same rule as that of Z-test, and it is again vital for us to calculate the probability whether that correlation coefficient result is reported again if some other sample is drawn from the same population. So basically that question makes us focus on the application of this T-test or Z-test or F-test in order to be sure whether the sample probability in this case is quite credible. So once we went through that, then we had a discussion on pitfalls of regression. We discussed in detail about that and found out that what are the discrepancies in this regression analysis and how they can be tackled. So there are many pitfalls, and in this case one has to be very cautious because there is very much little awareness for the conditions which are required for perfection for regression analysis. So these conditions normally are not known to many people, and that's why they just straight away jump to regression, and though they do give us the result, but again with the condition which is not credible, then based on that we cannot accept the result of that regression. Now if we have basically got reporting of basically anomaly in this regression, then we have to basically look for alternative options as well. So there are other methods as well which can tackle that more effectively. So based on that, again, this is very much vital that these pitfalls should be micromanaged, and it should be known that when at which stage would the regression may not give us the exact result, and the alternative should be calculated and should be prepared in this case. So once we had discussed the pitfalls for regression, we discussed about what are the strategies which should be followed to avoid such kind of pitfalls, and in this case one has to be aware of the kind of tests which need to be tested, and again one should take extra caution in order to ensure that all the assumptions are met. So these are various different strategies which we discussed while discussing about pitfalls in regression. Then we took the example of a typical data set, and we put it in SPSS and tried to find out how we can generate results in regression in SPSS and what would be the interpretation of such kind of examples which have been put in SPSS for execution. So based on that, we just discussed how R square is calculated and how we can find out that the F statistic is in which column reported and whether it's significant or not, and how it will impact our whole result in this case. Then we had also seen about the descriptives which were reported for each variable, but again it depends upon the user which kind of statistics he would like to be reported by SPSS. So there's a specific button for statistics in which you can mention that what relevant test statistic you need to measure. So based on your approach, you can easily take the relevant options and then you can get the results. So we were discussing in detail about the interpretation of these results, and I hope that this is easily understood by you. Thank you so much. Allah Hafiz.